Have you ever changed one line of code and suddenly 10 APIs stopped working? Or your team lead says, this code is tightly coupled. Please refactor it using solid. And you are thinking, what exactly is solid? In this video, I will explain all 5 solid principles using simple PHP example, real project scenarios, and memory tricks you will never forget. Hi everyone, welcome to Learn and Grow. Today we will learn one of the most important software engineer concept, solid principle. If you are preparing for Laravel interview, NestJS, Java interview, system design, tech lead interviews, this is the most known topic. Let's start. Memory trick. Remember solid. Think some old ladies inspired developer. Every letter represent one principle. S. First one is S. Single responsibility principle. SRP. Definition. A class should have only one reason to change. Bad example. Class invoice public function calculate total public function and save. So under invoice there is three abstract method: calculate total, save to database, public functions, send email. This class is doing calculation, database, email, three responsibilities. If email changes, invoice changes. If database changes, invoice changes. So what is the good example? Instead of three method under one class invoice, we break down into three different class. One is class is invoice calculator, and there only one method calculate total. And another class is invoice repository, there is method function save. Another class email service, the method is send. Now every class has one responsibility. So easy, for example, imagine a restaurant. One person if try to cook as well as serves food, cleaning table, collect money. It's impossible. How much difficult you can understand. Instead of that, one chef, one cleaner, and one cashier. So different responsibilities. So memory trick, we can say that one person, one job. Now I move to open close principle. O stand for open close principle. Software should be open for extension, close for modification. So what is the bad example? If you see the class payment, in payment there is a method pay and there is argument type. If type is equal to PayPal, then there is some logic. If type is equal to Stripe, then Stripe related logic. In future, suppose every new payment, what we have to do, modify the class. That is the bad approach. Suppose you want to integrate phone pay, Google Pay, so again you just update in the existing method. If type is equal to Google Pay, phone pay, like this, that is bad approach. What is the good example? Instead of that, we just create a interface payment gateway and pay is the method. After that, we just implement the interface payment gateway for PayPal payment, Stripe payment. So in this way, if in future we have to develop a new payment gateway like phone pay or Google Pay, just we create a new class and implement the payment gateway, so without disturbing the existing class. So just create a new class, existing code untouched. So easy example, phone charger, you don't replace the phone, you only plug another charger. So memory trick, add new, don't edit old. Now I move to the third, that means L, Liskov substitution principle. So the definition is child class should replace parent class without breaking code. So if you see the class bird, there is a method fly. If we create a new class penguin and extending the bird, for penguin is a bird who not fly, so throw new exception. So this is the bad example, penguin cannot fly, inheritance broken. What is the good example? So what we can do, we can create two interface. Instead of one interface bird and interface flying bird. Under interface flying bird, we can create a function fly. So easy example, car, electric car, petrol car, both drive. Good. Now bird, penguin cannot fly. So bad. Memory child should behave like parent. Now I move to the fourth principle, that is interface segregation principle. So don't force classes to implement method they don't need. Bad example. What is the bad example? Suppose there is a interface worker. Under worker interface, there is two methods. Suppose work and eat. Two abstract method, work and eat. Suppose I am trying to develop a robot class by implementing the interface worker. So on that case, I have to forcefully need to be implement work and eat both methods. Whereas robot never eat. So it's redundant. Robot cannot eat. So what is the good example? We just break down the interface. Interface workable, interface eatable. After that, we implement as per our requirement. So easy example, restaurant menu, vegetable menu, non-veg menu, kids menu, different people, different needs. What is the memory tick? Small interface, happy developer. The last in the last principle, that is dependency inversion principle. Don't depend on concrete class, depend on abstraction. So let's see the example, order service. Let's assume the class order service. The method is PayPal, variable is PayPal payment locked with PayPal. What is the good example? If you a class order service and construct payment gateway instead of any hard-coded PayPal payment, just we pass the payment gateway. Now PayPal, Stripe, Roger Pay, everything work. So easy example, you plug USB cable into laptop. Laptop does not care. Samsung, Apple, OnePlus. So what is the memory tick? Depend on interface, not implementation. So final division, what we can say is one class, one job. Single responsibility principle, one class, one job. O, add new, don't modify. L, child behaves like parent. I, small interface. D, depend on an interface. So real project example, if I saying that, imagine you are building a e-commerce application. So SRP, single responsibility principle, separate order service, payment service and email service. OCP, open close principle, add a new payment gateway, as for example Pay, without changing existing payment code. The third one is Liskov substitute principle, LSP. Any payment gateway, Stripe, PayPal, Pay should work whenever a payment gateway is expected. And ISP, interface segregation principle. Don't force every integration to implement refund method if they only support payment. Last one, dependency inversion principle. Inject a payment gateway interface into your service instead of creating new Stripe payment inside them. This is how solid principles are used in real world application. Now tell me in the comment, which solid principle do you struggle with the most? I will create a dedicated deep dive video with real project example. If this video helpful you, don't forget to like, comment, just capital solid SOLID. Subscribe to Learn and Grow, because every week I upload backend development, AWS, Laravel, NestJS and system design tutorial and help you crack interview and become a better software engineer. Thank you.